So I'm going to start by posting a link in the chat to a gist. And if you pull up that gist, there's a link at the top of the gist to some slides, which is what I'm going to present. I want this to be an interactive, session in kind of two ways. One, feel free to interrupt me if you have questions along the way. And two is towards the end, or if you get anxious and you want to scroll to the end, I'll have you guys sign up on our website, and then you can actually program your own autonomous car. And we'll actually all be in the same virtual room, so the autonomous cars can interact with each other, run into each other, etc. So, yeah, please open those notes, and I'll share my screen and get going. Okay, so yeah, my name's Ryan, and I work on my own startup, which is called Master AI. And so it's interesting, the previous talk, we ended up talking about education, teaching kids. I mean, that's what we do. We teach kids Python, and we try to make it fun, entertaining. I think we do a good job of that. The kids get real excited with our stuff. And we find that around age 7 is about when kids can start doing Python, very, very basic stuff. Age 5 is a bit too young. So a few warnings. One, these are new slides. I just made these today. 2, we're going to be dealing with new software. I just finished it today. And 3, AWS might go down because, you never know. So, just we'll kind of see how this goes. Kind of another warning is typically we have a long curriculum that we have students go through, but a lot of the people here are practitioners, and so we're going to skip the curriculum and just kind of hammer all the fun, interesting points in these slides. So about our company, I mentioned this a bit already, but basically what we do is curricula and education products. So we teach Python, we teach computer science, AI, and robotics. And our flagship product is called AutoAuto. At first, we had only the physical AutoAuto cars, which 3 years ago, I did a demo at this meetup. It was like almost 3 years ago exactly. It was December 2018. So I don't know if anyone's here from that, but you guys saw the physical AutoAuto car. Yeah, I see Jacob. We were doing J-turns, and it was a lot of fun. But today, we are going to be using the virtual AutoAuto, and because everything's virtual these days. So like I said, if you guys kind of get bored, I'm going to go through some of these coding examples. If this is trivial, feel free to go register for the website while I'm talking. There's instructions at the bottom of the slides, or feel free to just kind of tag along with me, and we'll sort of go over this code together, and then we'll all jump in the virtual world at the end. So the programming API for programming the virtual car is the same as the physical car. So in both cases, you import car, and you can do car.forward, car.reverse, car.left, car.right. So this is where 7-year-olds can understand what's going on with this, and even a bit more than this. And we really try to teach Python at the most young age possible. We find that the students feel excited about it because, like Greg said, they understand that they're doing what the adults do, what the professionals do. So as the parameter of these function, you give an integer or a floating point as well, which is time in seconds. So see car.reverse 2, we'll go reverse for 2 seconds. This is the most basic API. And these calls are blocking. So while you're going in reverse for 2 seconds, your code is paused right there, and it's not going to move on. The reason I mention that is because later on we'll do more asynchronous stuff. The physical and virtual cars have cameras so you call car.capture, and it returns a NumPy array. And then you can call car.plot, and it'll stream the frame into your browser, so you can see this is all browser based, so you can see the picture you took in your browser. If you know OpenCV, if you've ever used OpenCV, or if you want to learn OpenCV, this is a fun way to use it, because the cars have OpenCV installed in them. A lot of what we do internally in the car libraries, we have like the face detector for the cars. It's all using OpenCV under the hood. But of course, you can just use OpenCV in your own program. So this is just a simple program that's using car capture, converting it to a grayscale using OpenCV, doing an edge detection with OpenCV, and then streaming that edge image to the browser. I did a demo of this actually 3 years ago at this meetup. So moving on, again, I'm kind of moving fast because you guys have these slides and you have the markdown notes where you can copy this code. So you don't have to like memorize all this. All right, let's talk about device capabilities. So we're getting a bit more advanced here. So from auto.capabilities import acquire. Acquire is kind of is the function that you use to acquire the device capabilities. And the device capabilities have string names. So for example, we'll acquire GPS as a string. And the reason for this is this allows us to have these components be pluggable. So if you buy a new sensor and you plug it into your car, it'll be like, oh, I know that sensor, and it'll give you a new capability that you can actually query the device to ask what capabilities it has. It'll give you a list, and then you can acquire that capability. In this case, we get the GPS sensor, and we can call GPS.query. In the virtual world, this is a bit different. In the virtual world, it just gives you Cartesian coordinates. In the real world, it would give you geographic coordinates. But that's, I think that makes sense. So that's the example on the left. On the right, we have a different capability, which is weapons. The virtual world has weapons. The physical car doesn't yet, but maybe in the future it will. So in the case of weapons here, what we're doing is we're acquiring our weapons, and then we're just in a infinite loop while true, we're going to fire that weapon, and we'll fire it kind of with theta going around in a circle. And I'll just demo this one so we can really appreciate it. So this is what you guys will be doing in a bit. Okay, so here's our virtual world, and I just pasted in that code we were just going over, where we're going to fire the weapon like around in a circle, you know. And the zoom box is in my way. Hold on. Okay, there we go. The weapon is a soccer ball. We'll come back to that weapon later. Real briefly though, the parameters. So theta is your angle in the horizontal plane. Phi, these are like polar coordinates or spherical coordinates. Phi is your angle from the vertical axis down. So phi 45, you know, it's just halfway down from the vertical axis. That's why it's kind of shooting 45 degrees in the air. And then velocity, of course, we can shoot them faster if we want, or slower. Let's go back to our slides. You can follow this link down here. It goes to GitHub, where you can see all of the capabilities that devices have, and also their interface. So like what method you can call. All right, so here's a challenge, and you can start this now if you want, or wait for later. But you'll have to pull out some of your old trig, you know, your trig knowledge. Maybe a while for some of you guys. So what we're going to do is we're going to acquire the GPS and acquire the compass. That's right here. And we have some target in the world that we're trying to get to. So the XZ plane is the horizontal plane in our world. Y points straight up. So we're trying to get to like -55 in the X and 55 in the Z. And the way we're going to do it is we have an infinite loop where we're going to query our GPS and query our compass. And then we need to do some sort of math, because we have to figure out what angle do we turn our front wheels. And well, that's really the main thing. What angle do we turn our front wheels? Then we can just kind of start driving, driving and turning our front wheels. We're going to try to get to that target location. So there'll be some sort of, you know, trigonometry involved with this. So you guys can work on this challenge a bit later. There's this to-do section that I left for y'all. Once you were to accomplish that, you could actually start racing your car. So let me go back to the world and I'll show you what this looks like. So you may have noticed from before, but this is our kind of virtual classroom environment. And it has this track that goes around it. And in the future, we'll have like F1 tracks and stuff, but for now we just have this one. So that I've created for you some checkpoints. So all these checkpoints are, key points of the track that you need to turn, like basically, the parts of the track that bend to some extent. So there's, checkpoints all the way around the track. And I've given those to you. And so let's go back here. So if you were able, on the previous challenge, if you can get your car to one point, one destination target, then you can get to the next one and the next one and the next one. So this is how we'll have our students, go around the track using the GPS and the compass, and then using these checkpoints. And I can show a demo of that later. It's a bit in it, but what's interesting about this, and we're going to set up where we have a bunch of schools that have our product, of course. And what we're going to be setting up in the next semester is competitions where students at schools can enter and race against each other, because this gets more complicated than just following the checkpoints, because how fast do you go? If you go too fast, your car will actually roll over. You don't want that. If you go too slow, you won't win. If you don't avoid the other cars successfully, you'll be running into cars and just getting in pileups. So there's a lot that can go into this. There's really kind of no end to it. Eventually, you'll just be a researcher at Google, like researching autonomous cars. So let's talk about more capabilities. So there's recon, which is short for reconnaissance, and weapons. And this is a challenge for you to use the recon sensor to do a binary search and find an enemy. So the way that the recon sensor works is, I don't know if you can see my cursor, but I'm here on the left, kind of in the middle, where it says left vins equals something and right vins equals something. And you'll see for both those calls, we do recon.query and we pass in theta1 and theta2. So again, theta is your angle in the horizontal plane. And so when you query the recon sensor, you give it a range between one theta and another theta, and it'll search that range for enemy vehicles. And it'll return to you a list of their VIN numbers if it finds any, or it returns an empty list if it doesn't find any. So of course you can set up a binary search to search that space. You search the left half of the world and the right half, see if there's enemies. If there's enemies in the left, you can just, you narrow your space to the left. You search, quarter space after that, and then an eighth, and then 32nd, et cetera, or 16th, 32nd. So there's a to-do for you here to finish this binary search. And once you get your theta range really narrow, like for example, I have here within 1 degree, if you narrow down the enemy within 1 degree, you have a pretty good idea of where your enemy is. And then in this next part, you're going to fire a soccer ball at them. So this is how you can quickly binary search and find enemies. So that's a challenge you can work on. There's Python Async Io, which if you want to get real advanced. So we have, if you start playing in this world, you'll quickly come across a few things that will be problematic. So for example, one is if you're querying multiple sensors. So let's say, in this first motivation, you're querying the GPS sensor followed by the compass. And we've had an example where we're doing that. It's really twice as slow as it should be. And this is true in the virtual world. This is going to be true in the physical world too, if you're querying sensors and your query is blocking on each one. However, and that's the code we've seen so far. It's like, it's going to block querying the GPS, and then after it gets back the GPS reading, it'll query the compass, it'll block waiting for the compass. Well, this is where Async Io is going to come in, because really what we need to be doing is we need to be starting the query on the GPS and the compass. And so we can wait for them in parallel and then just get back both readings around the same time. So it'll be twice as fast if we can do that. So Async Io is going to help us with that, but there's more motivation, which this next one's probably a bigger motivation. Let's say we have a car that is, he's racing around the track. So this car is using GPS and compass to navigate around the track. But as you're driving around the track, you want to be searching for enemies and firing soccer balls at them. Well, if you're in a blocking world and you're sort of doing kind of the trivial code like we've seen so far, if you start searching for an enemy, that might take a while because you're having to do this sort of binary search. It's pretty fast, but it's slow enough that you're going to have to stop navigating with the GPS and you're going to end up running off the road. Or vice versa, if you're focused on doing GPS and compass, you're not focused on finding and shooting enemies. So how can we do these things in parallel? Well, again, Async Io will help us with that. You could also do it in threads, but you're just opening up a can of worms. Async Io is really perfect for this kind of stuff. So here's an example. And this is like I said, this is getting really advanced, so maybe you don't care, but maybe you do. So there's a whole different, API that we publish for using everything is actually Async Io behind the scenes in the way that these cars work. So really what you're doing is you're just kind of tapping in one layer deeper in the software stack to sort of get at that Async Io stuff. So it gets a bit more complex. But the main thing here, let's look at, our application is just doing async io.run to run main, which is a coroutine. And then it's initializing the CIO root, which is the controller input output. That's what CIO stands for in this case. We're awaiting, see, now there's a bunch of awaits everywhere. So we're awaiting to acquire GPS, awaiting compass, et cetera. We're awaiting all these things. And then we create two tasks, and that's going to parallelize these things. So this drive task and the attack task will be running in parallel inside the async IO loop. So the drive task can just focus on driving, and the attack task can focus on attacking. And they're going to be running, they're just going to step right around each other, and they're not going to block each other's progress. And so you could study the code on the left if you want to, but just kind of want to introduce this idea. So with that, I'll have you guys register, and then we'll sort of all jump in this world together, and we can kind of start playing around. You guys are some of the first to see these new sensors. So I'm anxious to sort of see how this goes and to get feedback, and just ask me questions if you have any. I'll leave this. Oh yeah, go ahead.
Do you want this part recorded, or do we want to, kind of do things offline and then come back and record whatever hands up?
It doesn't matter too much to me, Jacob. What do you think we should do? I figure I can just share this screen, and what we'll see people's cars. I can even make it full screen.
Yeah, but I'm doing it, and I'm trying to figure out exactly what to do. So this is why, you'll have silly questions. Maybe you want to record them, and maybe not. It's like.
Yeah, I mean, I'm happy to stop the recording, and then we can,
No, it depends what you want. We eventually it goes upstairs. So if you want it authentic with the recording, then you will see. Or we can kind of make it. Oh no, this is what we ended up at the end. You decide. But in any case, maybe people have questions before we go on, and maybe the questions will give us more time. Questions, guys.
Yeah, I'm registering right now.
Yeah, I'm already registered. I'm the green car, but.
I think here, let me jump into, I need to get in the world that you guys are in. For the way that this works kind of behind the scenes is each classroom gets their own world where you see your peers' cars, but you're not going to see the cars from other people. So let me get back in here, and I'll jump. I think I was in the wrong. I wasn't in this classroom that we have here today. Okay, let's do here. Yeah, I see that we've got like 5 or 6 people already in here.
Yeah, but we haven't moved anything yet.
There's a classroom code, right, that we have to enter.
The instructions allow you to enter. Just the link. I posted the link. Anyone who's interested on the Meetup page, they can go in and just follow the instructions. They're at the very end, and how to just go to the very end, and then there's how to log in. There's some links there, and then.
Mm-hmm. Yeah, that's right. Here, I'll show what Jacob is talking about. So you can go to the bottom of the Markdown page. That link is in Zoom. There's instructions there. Or if you're in the slides, you can go to the last page or the second last to last page of the slides, and there's instructions there.
Okay. So there are all sorts of units, but how do you get to the point of actually getting to the code and moving the car?
So what you guys should be doing is going to the dashboard. So let me show you what, if you look at the screen share here, there's a menu on the top right called devices.
Yeah.
and you go to that first option that says all my devices, and you were here at one point to create the device, but then after you create your device, there's a big button that says dashboard, and you want to click on that dashboard button.
Yeah, I got it. Device is currently offline.
Yes, and then you turn on the device. It looks like a few people already in here. We've got at least four people here. So making some progress. And the most simple thing you can do is just import car.forward. It's the hello world of AutoAuto.
Import car, and then what?
Car.forward with parentheses.
Oh, it is doing something, that's for sure.
So we've got four people here. We've got Greg, myself, Paul, and Collier.
Yeah, I'm trying to join myself, but it's lagging.
Yeah. My computer's being real slow too with everything that's going on.
Okay.
Oh, there we go. Oh yeah, and yeah, you might have to be patient if you're trying to turn your car on, and it could take like 2 minutes, because it's actually scaling up in AWS to have more people.
Forward is a function, or forward is a?
It's a function.
Yeah, it is.
Oh, yep, someone's shooting okay, cool.
Oh.
Someone's shooting their soccer balls.
Okay, so you can actually move the car just without. Yeah, interesting. So what you're saying, the main.py, is it actual Python?
Yeah, this is it's a simplified, IDE. You can think of it. You just get one file, main.py. We don't have functionality to like create other files. Although,
can you print?
Yeah, you can print, and it'll print out on the console down the bottom right, and you can do input. It's a TTY console.
Okay, so how do you know what functions that car can do? Like can I do deal car and it will do it for me? Yeah, I'll try it.
So there's a lot of what you'll need is in the slides, and if not, there's more stuff in the GitHub repository, which I've linked to in the slides.
Yeah.
Yeah.
It's Python. It actually tells you all the things that the car can do.
Like, oh yeah, you can also do dir. Yeah.
Yeah, so it's basically you actually write Python code.
Yeah, it's full-fledged Python. I mean, you have NumPy, you have a slew of other libraries that are already installed.
Oh my God.
Yeah.
Huh. This is super awesome, man.
It's a lot of fun.
I don't know who said that, but thank you.
Yeah, it's Corey. I think my car's name is Corey. I'm in there spinning in circles.
Oh yeah, I see you. I think I pronounced your name wrong earlier. Yeah, so this is fun. Like our whole goal of the company is to make learning coding fun for kids. So this is our best attempt. But we've been using the physical cars for years with kids, and they love that. And then we rolled out the virtual car just this semester. Well, it's almost the end of the semester now. And so we've gotten a lot of very positive feedback on it from the schools that we're in. Although these sensors that you're using today are brand new, or some of the sensors are brand new. You may notice there's some indicators in the virtual world to kind of show what the cars are doing. So if you use the recon sensor, there's like a blue ring that shows around your car. If you use the compass, there's a little pin map thing, I don't know what it's called, that sort of appears above your car. Or sorry, not the compass. If you use the GPS, there's like a little pin that appears above your car. And then the compass shows a little compass above your car. So that way, if you're watching someone else's car, you can kind of see what they're doing to some extent.
This is fun.
let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 people here. So is anyone working on the challenges that I gave? There's two, well, there's at least 2 challenges. There's more with some imagination. The
We're too
first
busy having
challenge,
fun.
yeah, having fun is a great thing to do as well. So the first challenge was using the GPS and the compass to sort of navigate your car to a specific point in the world. If that interests you, that's going to require some trigonometry. The second challenge is the recon and weapons to sort of binary search to find where your enemy is and kill them. Not kill them, but shoot a soccer ball at them, which is probably death, I guess. But and then sort of a further challenge is to do both of those things together, but you'll have to use Async Io for that. I've tried it without Async Io, and it just, things are too slow. You have to do stuff more smartly in parallel to make it all work. One, two, three, 4, 5, 6, 7. Okay, I think we've got 10 people now. That's cool.
So Ryan, you said this virtual world that is created, is it Python?
Yeah, so the cars are running, full-blown Python, and they're running like in their own Docker container in the cloud, so it's full-fledged Linux Python that these cars are running on. Of course, they're talking over the network to sort of communicate with each other and all that. Yeah. But you have a full-fledged Python environment. You even have a terminal. There's a button on the lower left in the dashboard. You can open up a terminal, like a prompt. And then also the cars, if you're a fan of Jupyter, the cars all run their own Jupyter server, so you can even connect to Jupyter and do things in Jupyter. It's a little bit weird. It's a little awkward because you need to sort of have 2 monitors, one to see the virtual world and monitor 1, and next one to like see the Jupyter window. Yeah. But if you or you can make them small side by side, but that's not great. Anyway, but it's an option if you want to play around with that. And part of our curriculum, we actually teach terminal commands to the students. So we use the terminal, and then we even teach Jupyter a bit with some data science lessons.
So what is the command that you see if something is in front of you?
So you'd want to use the recon sensor.
Recon.
Well, you say something. The recon sensor will only tell you about enemy cars or other cars. We're developing a Lidar sensor, which is going to be, I think, maybe what you're asking, Jacob, but it's not there yet. It's not done. But eventually there'll be a Lidar sensor where you can sort of say, at this certain angle, like shoot my Lidar and tell me the distance. So that way you could detect walls and tables and stuff. But that's not finished yet. I was hoping to finish it, but I haven't done it yet.
Here, found it. Found my recon is equal. Got it.
Yeah, recon will tell you about the other cars. Yeah.
Will it give you a list back?
Yeah, it gives you a list of the car VIN numbers that it finds, or an empty list if it doesn't find any.
And the locations as well, or?
Not the location. It's just a binary thing. It says if it found it or not. So you'd have to binary search to narrow in the location.
Upside down.
You give it an angle. Okay, got it.
Yeah, and the angles are all in degrees, which I know is a little awkward. I kind of debated how to do that interface. I thought for the younger students who are just shooting soccer balls for fun, I thought degrees would be more friendly. But once you get into the trig stuff, you'll have to, of course, convert to radians if you're going to be doing trig stuff. So you can't win both. But anyway, point being, just convert to radians if you're working on like the trigonometry stuff. Anyone? Okay, so I also want to use this kind of environment to get feedback. So is anyone having any technical problems, or it's just not working? I'll look at the chat. I haven't looked at the chat in a while.
I feel like it would be great to have some documentation right there, or autocomplete,
Yeah, that's
something like that.
Mm-hmm. I agree. I think that's something that's valuable. We don't have good documentation right now. We just rely on the actual lessons on the platform, and then also the GitHub README page, which I know is not the best thing ever, but it's where we are. Okay, I'm scrolling up. Guys, scroll up away in the chat. I'm going to scroll down now and look for questions, but if I forget any, just hit me again. David says, cash king of the road.
I think I see an upside down car. What happens if your car turns upside down?
So there's a respawn button on your left. You can respawn. Search for a main to finish the research. Okay, David says, what is the planar surface? As the name implies, the planar surface is simply a surface is a plane word. Okay, I think David's just posting definition. How do I get my car in the scene? Sherry, were you able to solve that? Or I can, okay. Sherry says she's respawned. Okay, that's good. How do you see all the available methods of the car object? Like I said, we need better documentation. Right now, we have students go through some curriculum that's like video based, and so that's how we teach these things. But coming up at some point in the future, we'll have a more robust, documentation site. You can also run dir on the car. Doesn't really give you descriptive documentation, but it gives you something.
It will give you all the functions. It's good enough.
Okay, Scott, were you able to get it figured out, or I can speak to you if you want.
Not yet. I came in very late, but
okay. So,
I'm on a screen, but I'm not in the same one everyone else is in, and I think I missed the early links.
So so if you're in a virtual world by yourself, it just means you haven't joined the correct classroom. The classroom you need to join is the code name is Austin Python 21.
Okay.
So on the menu at the top right, you can join a classroom and then Austin Python 21, and then from there you'll be in the same room as everyone else.
Thank you.
Cool. Has anyone traversed the entire racetrack? I haven't seen anyone do it here. I have code to do it, which I can demo. If you guys want to see that.
We're having too much fun. You probably have better chance with the 5-year-old or 8-year-olds than us.
The kids do learn really fast. It's true.
Something you might consider too, like not for just learning Python, but you might be able to kind of teach some machine learning techniques by like letting an agent kind of control a car instead of like a child.
An agent as in a program?
Yeah.
Okay. Well, that's sort of similar to what we're doing when you write your program. But maybe I'm not understanding.
Well, I mean, like it would be totally bot controlled, basically, the car.
Mm-hmm. And then some of the machine learning stuff, we have more machine learning for the physical car, because when it takes a picture, it's like a real picture. And so, to do anything good with it, you need to like use machine learning stuff, neural networks.
Yeah.
So the physical car has more room for the machine learning, especially like in terms of computer vision. The virtual world also has a virtual camera, but it gives you like an image that's like too perfect, right? Because everything's just so perfect in the virtual world. So
Gotcha. Okay.
applying such extreme machine learning models is kind of a little bit overkill in the virtual world.
Mhm.
Also, in the virtual world, you can have more precise sensors, like the very precise GPS.
Yeah.
So so yeah, we kind of rely more on the physical car for like the deeper machine learning stuff.
Mhm. I can see that.
Question. Use the virtual button.
So can a teacher like see like from like a more like a dashboard, like all what the students are doing, or the teacher has to actually walk around and?
Yeah, let me do a quick demo of that. So here what I'm seeing is, of course, the virtual world. So that's one way a teacher can look, but I think you're asking more on the lesson side of things. So I'll show you that.
Yeah.
So you guys have just chapter 1 of our course. It's called the AutoAuto mini course. And no one's done anything yet. But if this was a real course, actually, some people have done some stuff. If this was a real course and I'm a teacher, I can come to this page, and it shows me, this is Unit 1, Intro to Programming and AI, and here are my students, which are you guys, and basically I see that no one's done anything except for a few people who've gotten something wrong. These X marks mean that something was incorrect. So I think this is what you're asking, is sort of a teacher tracking view.
Yeah, like for example, like seeing like what code people like they use, or like.
Mm-hmm. Yeah, that's right. And so if a lot of the exercises, the students will submit their final code, and in that case, there's a little bell that shows up on this page, and the teacher clicks the bell, and then it brings up the student's code for the teacher to review. I can't demo that since no one's done it.
Yeah,
I don't want to show a real classroom since this is being recorded, and
yeah.
we're sort of stuck here on this view.
Yeah, no worries. Yeah.
But if someone wants to go like complete a lesson, one that's not auto graded, some of them are auto graded.
On the I don't know if you want to answer that one, but on the business side, I know like school, like I've done some products for schools districts, and it's like pretty like slow process to adopt new things. So like how hard is it for you on the business side to actually go and practically sell the product? Do you have to go like RFPs or?
Yeah, that's a great question. It's something that if we had known what we were getting into 5 years ago, I don't know if we would have started the company. But it's the sales cycle for us is that we'll meet a teacher, do a demo, put them on our email list, and the teacher kind of goes dormant for 6 months to a year. And then out of nowhere, the teacher emails you and they're like, okay, we have funding, let's do this. It's just because for that 6 months or a year, the teacher's been working on finding the budget and talking to the principal and figuring out how they're going to do, where the money's going to come from. So the sales cycle is very long.
You have to go through the RFPs, I think they're called, like, or it just goes straight to the teacher. Like when I had my startup, we used to do with these like GPS. We install GPS devices in school buses, and like video cameras and things like that. So yeah, it used to take, as you say, like at least half a year to a year before we actually could make a sale, but I had to go through this RFP process, I think it's called, request for proposal or something like that. And you had to go to the school district. I don't think, well, in your case, it's a little bit different because it's direct. You practically selling something that is directed towards the students. So yeah, so you don't have to go like to an RFP or anything like that, right? Like
we've done in a few cases we've done RFPs, and in other cases we haven't had to. So it
Nice.
just sort of depends. And that's the other thing we've been surprised by is it sort of always takes a long time. That's the commonality between schools, is it just takes a while. But
Yeah.
the particular process from one school to the next, even if it's one public school to the next one, it can be very different. The kinds of approvals they have to have in the process. So it's there's not just kind of one pathway that we've, at least not that we've discovered.
Yeah.
There's sort of 20
Ryan,
pathways. Yeah.
Ryan, you might try the National Institute of Health. They have idea states, and they'll have better seed money in minority states. So if you try that tactic, I'm sorry I didn't get excellent questions with trigonometry. I've been going to NIH meetings webinar earlier today, and that's some of the things they talked about. And you can get supplemental grants for diversifying with minorities. And your product has an excellent accelerator for youth as far as explaining what is this number phi. And that's what a lot of children, why do I have to learn trigonometry? If you can show them this is what a cosine is, this is what a sine, and it's fun, I'm telling you, you need to channel it into minority. And there's the NIH and other channels or recruitment channels. And this is awesome. You've done it's so great. It's such a wonderful tool. And I just see so much opportunity in it. And just diversify your channels, and you'll find this is just too awesome. This is too great.
Yeah. Well, yeah. Thank you, David. Do you mind doing me a favor, since I'm screen sharing? I don't want to write this down at this moment. Can you send me an email with what you're mentioning?
You want my email?
Or if you'll send me an email with the advice you just gave.
Sure. Is your email on the?
Yeah, it's at the very bottom of the README would be good, but I don't want to forget what you just said, and so yeah.
Sure.
But NIH is usually more related to healthcare. And NSF maybe more.
Yes.
If
yes.
they have something in NSF, so I'm not sure how. But they do have some funding sometimes for K-12 and stuff like that. You just need to be able to get to it, which is typically hard.
Yeah, we've attempted a few NSF pathways, and it's usually a lot of work for.
It's difficult, especially for a business. But
yeah,
it's a challenge.
But this is awesome.
Yeah. No, thank you guys. I mean, we're pretty happy with it, but it's definitely hard to sell into schools, so. Okay, question here: is it possible to program my car to drive using up, down, left, right arrows? So the answer is yes and no. You can call the function input in Python, which takes input from the terminal. So you won't be able to use the arrow keys left, right, up, down, but you could use, like, if you do W enter, if you go forward, and A enter would be left. You could do something like that. Yeah. It's not quite as smooth as doing it, because you have to press enter, but that's sort of just a limitation of our terminal, The physical cars, we've had some students actually wire up controllers. We don't give that out of the box. It's something the students have to work for, is just wire up a game controller, and then they can control the car. But we sort of require that they write the code to connect the game controller to the car, and so they're at least having to code part of it. Because there are Python libraries for, like, reading game controller input.
And would you be able to log all the commands that they would have, kind of keyed in?
In the case of the game controller, is that what you're asking?
Yeah.
In that case, I mean, you mean like log in the sense of, like, the company keeping records of it?
Well, I mean, like, because you're pressing the right button would do this, these function calls, etc. And that might be useful to see.
Oh, yeah, I think I know what you're asking. It sort of depends on the game controller that you get. It sort of takes some trial and error depending on your game controller. Press the button and see what pops out.
Gotcha.
I've got 2 versions of game controllers I've used, like here in my office, and they're both different, you know. And the students we've had do it, like we sort of help them along the way because it's not super obvious how to get it to work. That's something we've considered making more part of the standard curriculum. If we could like sell a controller that we know works and we know how the code works, then we could actually have lessons on it and stuff, but we haven't gone that direction yet. Yeah, okay, so Sherry's asking if I'll demo an example of key input. Yes, I can do that.
How do you know your current position of the car? Is the router give-
GPS and the compass combined can tell you.
Okay, good.
Yeah. So Sherry's asking to demo kind of the keyboard command idea, so I can do that real quick because it's not very long. So import car, we always need import car. And then I'll say, you know, command equals input. I'll just do it like a little arrow, like it's an input prompt. And then you can say if command equals W, if command equals A, that would be left. I'll just try that for now before I finish it, just to make sure it's working so far. So I'll try W, enter. So driving forward. And then the next thing we should do is put this in a loop so it asks us over and over. So let's just do while true in the front of it all. And then we'll continue our elifs command equals S, reverse, command equals D, that's right. So that should be our complete program. So A goes left, W goes forward, D goes right, and S goes reverse. So that's we actually have lessons on this too in our curriculum. And then Sherry asks also to demo the entire traversal of the racetrack. So I have code that I have prepared for that. If my computer will not freeze on me, okay. So this code is rather complex, and there's a lot of people in the world, so we'll see how it goes. But what it's going to do is it's using Async Io, like I mentioned. It's using all the sensors. This is my green car. I'll follow it around. So and then I'll yeah. I don't know how well you guys can see, but I'm screen sharing, and we're following around my green car. Hold on, let me try to get closer to the green car. Okay, there we go. And so this is using Async Io. It's using the compass and the GPS for navigating the track, and it's doing that in one task, Async Io task. And then in another Async Io task, it's finding enemies and shooting them with soccer balls, which is kind of hard to see here just because there's so many soccer balls going around everywhere. But it's gonna be hitting people pretty precisely with soccer balls. Let's see. Maybe I'll zoom out a little, then we can see it kind of following the track. I guess you guys can watch this on your own computer too. I'm the green car that's going around the track. So is anyone does anyone else want to demo what they've done? If they've have something that they like, I'd be happy to let someone else demo something.
I was just
Maybe
moving
if someone's
forward
figured out
and
the
backwards.
trick function.
I'm now trying to get to the point that I'm doing the important stuff, but I was just having too much fun.
Yeah, no, fun is good. That's
Yeah,
totally
same.
fine.
I have a random bit of feedback or question or something. I don't know, but you kind of answered it with the while loop with the commands. But I just found myself wanting to, while I was just mashing around, like pause the execution of my script and just like run a couple short commands as in like a REPL type way or something. But I don't, is there like a way to open up like a, to like run multiple scripts simultaneously or something? Or is it limited to just this one right now?
So if you stick with just this learning environment that you're looking at, you kind of you have just this one file main.py. However, if you want to sort of go a bit deeper, if you're looking at my screen share, on the bottom left, there's a button that says info for advanced users.
Yeah.
And you can click on that. And then if you're familiar with Jupyter Notebooks,
that's perfect. Yeah.
Yeah.
That's perfect. That's awesome.
It kind of, to get the full benefit, you sort of need two monitors. You can put like the virtual world on one and the Jupyter on the other. Just otherwise it's sort of frustrating to switch back and forth. But if you have something like that, that could solve what you're trying to solve.
Yeah, that's exactly what I was wondering. This pairs super well with the Jupyter Notebook. Well played, sir.
Cool. Yeah. And obviously the same library you can use, Cardot4 or whatever you want inside Jupyter.
Yeah. Really wish I had this when I was a kid, man.
Oh yeah.
Yeah, a lot of teachers have told me that this reminds them of Logo, Turtle, but just like better. So I take that as a compliment.
So it seems like the setting this to schools is a bit more difficult. Have you thought about maybe like setting directly to directly to the consumers, let's say to kids or parents or?
Yeah, we have had a few consumer sales, basically parents who buy it for their kids, but it's not our primary like revenue source. Even though it's hard to sell to schools, we still are making most of our money that way. That could just be a lack of marketing. I'm not sure. So it's sort of, we'll see what the future holds for that. It's kind of unclear.
Oh. This is fun. I'm trying to try a random walk.
Yeah, I'm doing a random walk. It's like I go like left, forward, right, left, reverse. It keeps going all over the place. Sometimes it gets stuck.
I'm trying to random on your code to see like you said that you can change the throttle and stuff like that. So I'm trying random numbers. Let's see if this works.
Let me show the GitHub page, because again, that's our best source of documentation.
Okay, let's see if this works. They have no random.
So I will show here.
It's random. Yeah.
Somewhere. You can scroll through the README page on GitHub and it has some good stuff. So for example, precise steering down kind of maybe halfway-ish. So the set steering function, which one of the examples in my slides has this, the input values are -45 to +45. +45 is like a full right-hand turn, which is approximately the wheels at a 45-degree angle. -45 is a right-hand turn. It's roughly corresponding to the angle that the wheels sort of turn the front wheels. So it gives you very precise, steering capabilities. And then set throttle is down here, and it ranges from -100 to +100. -100 is full throttle backwards, and +100 is full throttle forward. And for both the physical and virtual cars, you probably don't want to do full throttle because it's kind of too fast. But I kind of like that it's too fast because, might as well. That's like, if you guys remember my 3 years ago when I presented physical AutoAuto, we did like, we were using set throttle 60 to like basically peel out the tires of the physical car. And going much higher than that actually like would kill the Raspberry Pi because it would pull so much current from the battery, the Raspberry Pi would get starved. So you can't really go above set throttle 60.
Throttle will be the acceleration. Let's check. Okay.
Oh, someone's honking.
Yeah.
Okay. So you can get stuck.
Yeah, so I realized like as long as you have a reverse, you eventually get unstuck. Unless you go upside down, but
So Dennis says, from a kid's perspective, it would be great to see the actual cannon that shoots the soccer ball. I agree, there should be a cannon that comes out of the car. We go around the track and shoot soccer balls at the same time. I think that was asked before I had done it. Oh, sorry, this is scrolling a lot.
This is cute.
David says he has to leave.
Yeah, it's an end of the year party again. Last time you also were at the end of the year.
Yeah, it was December last time I did it.
Yeah.
Maybe this can be just a December thing, because Jacob, just ping me every year and I'll try to.
Oh, very easy. Soren, you're booking him next December.
yeah.
Those are awesome presentations.
Yeah, see the evolution of the product.
Yeah.
Whoa, this is cute. Whoa, someone here is like really shooting. Oh.
Better get ready to get out of the way, Jacob. I'm coming for you.
Oh no. Oh, no. You know what? I'm responding. Here we go. I can see why kids want to go and learn this. This is great, and this is Python. This is really, really great. How do kids react to the errors they are generating? Do they get stuck, or do they ask you? How does it go?
That's a good question. What we've tried to do in the lessons and the videos is go through the common errors that we see. Because if we just cover like 4 of the most common errors, that's like 99% of all the errors that happen. And so that's how we've dealt with it. Although there are still cases where we'll get an email from a teacher asking like, hey, can you help me with this? Because we don't know what's going on. And so we'll just try to support the teacher in those cases. Sherry has another good question. So there's these camera controls at the bottom if you haven't found those yet. So there's this drag and zoom mode, which is what I've usually use. You just click on and drag around. You can, if you're on a trackpad, you can click with 2 fingers and drag and it'll pan. If you're on a mouse, you right click and drag and that's panning. Follow mode will follow your car around. What you might want to do is kind of zoom in on your car like this, like I'm doing here, and then click follow mode. And then now when your car drives around, the camera will follow it. And then car cam is as if you're sitting on the camera that's in front of the car, so you can watch from that perspective as the car drives. So I'll run my code and with car cam, and then we'll see it kind of first person view.
And how are kids at those ages? They know enough trigonometry to actually be able to solve some of those problems, or do you teach them that?
Yeah, that we have to have like high school kids who've done trig. So we have different versions of the curriculum. If we sell in middle school, we don't include, certain lessons that are too hard. That's how we deal with that. Sherry asked if I'll demo going up the ramp. Yes, I can do that. That's the very first challenge that we give to students in our curriculum is get your car up on a table. You just have to do car.forward. So I will respawn at the ramp, and there's a soccer ball in my way, but I will try to get the soccer ball out of my way. It's hitting me. It gets to be hard when there's a lot of people in the room. Do about 3 seconds. And I will respawn because I got hit, and then do car.forward.
I think you're
try again. Respawn, and then car.forward. I think I got it this time. That's actually pretty cool first person. So I did the easier ramp because there's 2 tables, so it's easier to land on. You can do the same thing with the other table, but you just have to kind of figure out how many seconds to go forward. If you go too many seconds, you go off the table. If you go too few, you stay on the ramp. I won't give it away though. You kind of have to just try a few times and see what the right value is. I'll try 3 for you, which is going to be too many. Or no, sorry, it's too few. Because I just stayed on the ramp. Oh, I see. I just landed in. I just saw one of the random walk cars. I think it was Jacob.
Yeah, I'm trying to solve some random algorithm that will figure out how to stay on this. Everything must be random with me, so I'm trying to get to random algorithms. So it's like, how do you randomly get on track? So
randomly get to the track?
Yeah, like something like you start going in direction randomly. If you don't like it, you go back. And like and then you try randomly again. If you get closer to the point you need to be in, you continue.
Yeah, I thought about that earlier today, and so we're on the same wavelength here. I was thinking about trying it, but I didn't have time. But yeah, I think that's an interesting challenge because basically you're saying like I'm not going to use the compass, and I'm just using the GPS and sort of seeing if I'm getting closer or not.
Yeah, I don't want to do trigonometry. I want to be able to actually take a step and see whether it's better or not, because many optimization algorithms go like this.
Right.
So it's like you take one step in the direction. Are you closer to your target? Are you farther? And this is actually how you teach them optimization, which is the base of machine learning. But for this, you have to tie it within all those loops and all those things that you do have. So I'm trying to do it, and also get unstuck, because here, if you get stuck, sometimes you have to go reverse. So the reverse I already plugged in. If my distance between my last point and my current point is smaller than this, then I go reverse.
Right.
but I have to figure out the small little details now. It will take me a while.
Yeah. Well, I'm curious now, so I'm going to keep watching your car here. So no pressure.
Yeah. It's being recorded, you know.
Yeah.
It's going online.
Hey, Ryan, quick question.
Yeah.
If I respawn in the middle of a Jupyter notebook, do I have to like, I'm getting like this error message,
Oh, yeah.
can't drive this device.
I've seen that before, and that's a bug, which
Okay,
I don't
gotcha.
know what the problem is, but you just restart the kernel in Jupyter.
Okay, cool.
It doesn't happen every time, but I've seen it happen like enough times that I'm not surprised you're getting it.
Cool.
I'm curious, who is it that's trying that? I can't see who's talking in this.
Corey, I'm
Corey,
Strange
okay.
Loop car.
Okay, yeah, cool. Thanks for letting me know.
Yeah, no worries.
I'm gonna try to find you now.
This is cute.
Strange Loop. Okay.
So Ryan, how can we sign our kids up for a class?
So we work with. Are you in Austin?
Yeah.
So we
Well,
work
I know
with,
there's a lot of online classes. Everyone gets used to this whole online thing with the COVID.
yeah, we don't offer online classes. You know, arguably we should, but we just don't have the manpower to do it. But if you're in Austin, we've worked with a place called Hello World Tech Studio, and they've actually used our product in some of their classes. But generally, we've just worked with people who run it, and they always have really good content. So, and they're based in Austin. I think they have virtual stuff since COVID. So I'll check that out. Hello World Tech Studio.
Thanks.
Yeah, and then another one in Austin that we've worked with less, but still some, is Code Galaxy. So you could check that out too.
Huh. Okay.
So as far as your business model, you're trying to sell the tool to people that are going to do the actual teaching.
That's right. Yeah, we sell the tool. So we sell to schools and teachers, and then the teachers turn and use it to teach students.
Gotcha.
Mm-hmm.
Yeah, so you're selling the curriculum, but then the teacher actually follows through.
That's right. Yeah, and we do what we can to make it easy on the teacher. Like we have the video lessons and stuff, and we try to have auto-graded Python challenges where possible. But it's still, you know, the teachers who use our product are you know, they're very good teachers because they're willing to try to teach Python, which is bold, you know. And we always appreciate the teachers that are willing to kind of go outside their comfort zone in a lot of cases and like teach Python. So, and we try to do our best to support them really well if they have questions.
We did have a teacher regularly here for quite a while. So we should connect you. Okay. Try something new.
Ed Sidney looks like he's doing something intelligent with his car.
If by intelligent you mean a series of pre-written commands.
Oh, is that what that was? Okay. It looked like you were following the track.
Yeah, so Ryan, probably gonna have to stop the recording because the file might get a little too big.
Yeah, that makes sense. Well, I've said everything I have to say. So thanks for having me. We'll try it. We'll try it next year. Just ping me, and let's try to find something else to present next year.
Well, it's a challenge for you, but a pleasure for us.
Yeah, it was a lot of fun. Yeah.
Yeah, it was fun, man.
Yeah.
Yeah, well, thanks everyone for the
party.
encouragement. And running a startup is kind of grueling. So
yeah,
having people say nice things, kind of keeps you going. So I appreciate that.
Yeah, it's a lot of fun. I feel like a kid again.
Yeah, me too.
Oh, yeah. And
It was super fun.
It's awesome.
All right, thank you so much, Ben. Let's give.
Well, I'm gonna drop off, but y'all feel free to stay and play around if you want. I mean, you have the account, it's yours. So
Definitely.
Okay.
Yeah, thanks everyone.
Keep up the good work, man.
Yeah,
All right,
thank you.
Thank you.
Yeah, good work.
Thank you.
Thanks. Talk to y'all later. Bye.